So for worked example 3, we have a particle projected horizontally once again. This time we don't actually know the horizontal component of the velocity. We're given it as capital U in the question here, meters per second. So I've also indicated this on the diagram, so you can see a horizontal projection to the right. And this is from a point 122 meters above a horizontal plane. So if we just label this distance here, 122.5 meters, I should have said, above the horizontal plane, that's that distance there. The horizontal plane is the line parallel to the horizontal projection at the bottom. And the particle hits the plane at a point which is a horizontal distance of 90 meters away from the starting point. Okay, well, because we're working in horizontal and vertical planes, we've got 90 degrees between them. They are perpendicular, as we know, and this is 90 meters. Okay, that horizontal distance. And the point in which it makes contact with the ground, with the horizontal plane, is right there. So we know vertical and horizontal displacements. We don't know the velocity. What we have to find out is what that velocity is. So let's see what we can deduce from the Suvat equations. So let's look horizontally first. Now I'm going to take to the right as positive once again, and I'm going to indicate my frame of reference on the diagram. So horizontal to the right is my positive x direction, and vertical is my positive y direction. So I'm just going to indicate that as well. So that's going to be positive, and that's also going to be positive. So let's write down our Suvat components. So SUVAT. Okay, these are horizontal components. So I'm just going to put my subscript in there as well. And we're going to label what we know. So we actually know the horizontal displacement this time. It's 90 meters. Okay, the horizontal velocity is capital U, meters per second. That's what we're trying to find. We know nothing about the final velocity, but we also know that the acceleration is 0 because there's no force acting horizontally. We're neglecting, or we're negating all wind resistance and things like that. Okay, so now we've got all that, we can just sort of highlight what we know. We know the displacement, we know the horizontal velocity, we know the acceleration. We can figure out V or T, it doesn't really matter. So let's, before we do anything, let's just have a look at the vertical direction and see if we can do anything with that. So vertically, we've got same letters, of course, but these are going to be the vertical components. So SY, UY, VY, and AY. And we can indicate what some of these values are. So we know the vertical displacement, and we've also said that this is a downwards displacement. It's going down, okay, because it's acting under gravity. So that's going to be negative. So we're going to have negative 122.5 meters for my vertical displacement. For the vertical velocity, okay, it's going to be 0 again. It's as if it's fallen from rest. And the other thing we know is the acceleration is negative 9.8 meters per second squared. Again, because we're taking upwards as positive. So it's a deceleration. Now, what's tying them together, these two reference frames, or two components, I should say, is the time. They're common to both. So we need to find equations in both the horizontal direction and the vertical direction with time in, so that we can combine them and figure out what capital U is. So we need to find an equation that contains S, U, A, and T, and S, U, A, and T here as well. So it's the same equation we've used over and over again. So it's S equals UT plus 1/2 at squared. We'll do this for the horizontal component first. So horizontally, S is 90. U is capital U. And time we don't know. We'll use T for that one. And we have no horizontal acceleration, so nothing to add there. So we now have an equation with U and T in it. So we'll just write that down. I'm going to put it in a box. So hopefully we can do something with that in a moment. There we go. Now let's have a look at the vertical components. So upwards, we have got S is equal to UT plus 1/2 AT squared again. And the vertical displacement is negative 122.5. That's equal to 0 multiplied by T. So that's going to be 0. And then 1/2 AT squared. So that's going to be subtract 4.9 T squared. Okay. Let's just make everything nice and positive. So we're going to have 4.9 T squared is equal to 122.5. If we divide through, okay, we divide through, we get T squared is equal to 25, which means that T must equal 5 seconds, which has worked out rather nicely. That's exact. So that's good. So we've got time. And as we know, time links both horizontal and vertical components together. So the time must be the same for the horizontal component as well. And that means we can now figure out what capital U is. So when T is equal to 5, we're going to get 90 is equal to U multiplied by 5, or in other words, 90 is equal to 5U. And if we divide through by 5, we get U is equal to 18 meters per second. Okay. And we've got the initial speed of the particle.